5. Let's just read it real quick. Calculate the forces Fa and Fb that the supports exert on the diving board of figure 949 when a 52 kilogram person stands at its tip. A, ignore the weight of the board. B, take into account the board's mass of 28 kilograms and assume the board's center of gravity is at its center. All right, so with this problem, as all the other problems in chapter 9, we're going to be dealing with forces and torques. So let's just go ahead and call this is a picture of our diving board, right? And all the forces acting on it. So there's two supports here on the left side, one at A and one at B. And then we also have the center of mass here, as well as the person. So the person's mass is going to be big M, center of mass is little m, or the mass of the diving board. And the supports are going to do some different things because we want to define this corner, the left corner, as our pivot point. So when we have a pivot point like this, we want to we have to recognize that whenever we have a force acting at a distance, we have a torque, and so we can talk about the sum of the torques or the sum of the forces, whichever is more useful. And in this case, it's going to be both of them eventually, but let's just figure out some things first. So the distance from A to A is the center spot. This is just going to be 0, right? So this is the reason we're not going to include Fa in any torque calculations, just because it's at the pivot point and there's no torque involved with that force. If we move the pivot point, of course there would be, but we're not. So the distance to B is just going to be 1 meter, and the distance to the person is 4 meters, right? Now I could also have distance to the center of gravity or the life board, that is 2.0 meters, right? So these distances are going to be useful, but we should just get a lot of quantities out of the way. So let's see. M is going to be equal to 0. So we're assuming 0 kilograms first, so for number 1, but then for number 2, well, for part 2, this is more for part A, and then this is for B, is that M is going to be equal to 28 kilograms. So we're going to change the mass of M, but first we're just going to work with this for now. Big M is always going to be 52 kilograms. And we don't know the forces yet, right? So let's find out. So like I said, we can use Newton's law, sum of the torques. And in this sense, we can just look at our free body diagram and say, well, where are the torques being caused? So here's one. This is going to be, if we chose counterclockwise as our positive direction, then FB is going to be positive, acting at a distance dB. There's no center of gravity calculation because the diving board is massless first in the first part of the problem, and then the person's weight is 52, so there's going to be a torque created downward here to counteract FB. So we just have the two torques, FB dB minus mg times 4, and that's what we have here. If we go back, okay, times dp, but it's still times 4. And that all equals to 0. Well, this is a very important condition. Why is it equal to 0? Because we're in equilibrium. Because the diving board is not moving at that moment, we're allowed to say this is equal to 0, and then we can solve for the B force. And so it turns out, if you multiply everything through your algebra, you get, it's about 2,000 newtons upwards. So we already know the direction of it. We just found the number here, really. But if we go back to our picture, we find out the number, it's 2,000, and we'd already know it points upwards. So we can just say that FB is 2,000 newtons pointed upward. But to be exact, it's 2,038. For part A, FA is the same, but now we want to do the sum of the forces instead of the torque. So the sum of the forces is equal to 0, 2. If we go back to our free body diagram, there's no x forces, so we can just talk about summing the forces in the y direction. So we have 1 up and then 3 down, right? So let's go ahead and go back to our thing here. Now we have 1 force up and 3 forces down, but little m is 0 in the first case, so we can ignore that. So it's just 1 force up and 2 forces down, FA and big mg, which we see here, right? So FB is going to be above the line, it's positive, and the rest are below, that's why they're negative. And we do the same thing. It's in equilibrium, so we're allowed to say it's equal to 0, the sum of the forces. And then we just move FA to the other side and calculate. You should get 1500 newtons downward. And we know this because at our pivot point, we know that the force is going to act downwards. Okay, now for part B. The only thing that changes here is we let m equal 28 kilograms. So we essentially just need to do the same calculations as we did in page 2 and 3 right here, but we just need to include little mg. So that's exactly what we do. Same process again, or actually, yeah, let's go to this one. So some of the torques, we have FB like before, mg like before. Oh, I forgot to include the distance here. Let me do that. So there should be a 4.0 meters here before the 0. So force times the distance, b times 1 meter. Now we have the center of mass, force times the distance it acts at, and then we have the person, of course, acting at 4 meters. And so moving FB over to moving everything else to the right side of the equation, leaving FB alone tells us that FB is going to be 2600 newtons upwards. So the direction doesn't change, but the magnitude changes. How much did it change by? About 600 newtons. So same thing for this one. Now instead of FB minus mg minus FA, we just have an m minus mg in the middle, minus little mg. And we do the same thing we did before. It's equal to 0 because of equilibrium. And FA is equal to FB minus big mg minus little mg. And these simplify because FB is actually equal to 4 big mg, so you can get 3 mg from that, which is here at the bottom, and then little mg will go away. Well, the negative little mg will become positive from the 2 mg that's built into FB, the new FB now, because we calculated FB actually to have 2 mg in it here. So we need to include that on the FA calculation. So for part B, FA is going to be, after calculating all this, is going to be about 1800 newtons. 1803 to be exact, but yeah, that's the idea.